The universe is expanding faster and faster, but not all scientists agree on the reason. The main theory is based on dark energy, a mysterious something influencing the entire cosmos. But an alternative idea states that our universe might be growing after continuously colliding with smaller, baby universes. Let's try to figure it all out. The cosmic microwave background is leftover radiation from the Big Bang. While examining it, astronomers realized that our universe is going through accelerated expansion. This observation had to somehow fit with the main theory of cosmic evolution, so scientists suggested that the universe was filled with an enigmatic substance that was later dubbed dark energy. They thought this energy could encourage the expansion. Strangely, this elusive form of energy can't be detected in any way. That's why many astronomers question its existence and try to explore other possibilities for the expansion of the universe. One of the more daring ideas is that our universe is growing by constantly merging with other universes. The idea of multiple universes interacting with one another isn't new, but the newest study has developed a mathematical model. It can help us explore the hypothetical impact of such an interaction on the evolution of our universe. According to the researchers' calculations, merging with other universes could indeed increase the volume of our universe, and our instruments could actually perceive it as the universe's expansion. The researchers also claim that their calculations fit with the observations of the universe more closely than the traditional standard cosmological model. It also deals with the problem of the super rapid expansion that happened in the early moments of the universe. Previously, physicists proposed that this expansion could be caused by the inflation. That's a hypothetical field driving the ultra-rapid expansion of the universe in the very first milliseconds after the Big Bang. However, the authors of the new study suggest that super-rapid early growth could have been the result of our baby universe being absorbed by a larger one. At the moment, there is no detailed description of what such a process could look like, so it's difficult to judge if such a scenario could actually take place in the early days of the universe. But if this idea turned out to be true, then there would be no need for an inflation field. After getting absorbed, our newly enlarged universe might have continued colliding with other smaller and younger universes, incorporating them as well. This theory allows us to solve some pretty important problems of modern cosmology. Unfortunately, only observational data can prove whether it's correct. At the moment, many experiments are being carried out to study the properties of the microwave background and find some proof. So maybe we'll get our answer soon. Speaking about the expansion of the universe, we can't but mention the dark flow theory. In 2008, scientists discovered that a few galactic clusters were heading in the same direction at a speed of more than 2 million miles per hour. Could it be something giant and invisible calling them? It might be literally anything. A super large chunk of matter with strong energy, or some weird bending in space-time with insanely powerful gravity that actually comes from other universes. At the moment, the clusters seem to be moving along a line extending from our solar system towards Centaurus. But the direction of this movement is kinda uncertain. Most data indicates that the clusters are moving outward, but some scientists say that the opposite flow can't be ruled out yet. The dark flow theory is pretty controversial, since the distribution of matter in the observable universe can't explain it. The existence of this flow suggests that there's something beyond the visible universe that's pulling on the matter in these clusters. Now, let's dwell on the theory that tries to explain what can be found at the edge. This one talks about multiple universes. Some experts think that our universe might be a very small bubble somewhere in the middle of a whole array of other bubbles. The idea states that, from time to time, all these bubbles can come into contact with one another. Gravity can flow between them and make a mess, and when they connect, a new Big Bang can happen. We've never sneaked a peek beyond the edge of the observable universe. If we managed to get there, we could probably find another universe. There's an idea of parallel universes. Each of them looks exactly the same as our universe, and still, some details differ. In one of them, instead of choosing our current profession, you started a music band or became a world-famous chef. Maybe one infamous asteroid changed its trajectory, and dinos are still roaming Earth in that universe. But the multiverse theory takes it all one step further. Those who believe in it state that there might be countless realities with different life stories. We live in a bubble that is just one of many other bubbles. It looks like bath foam, and these bubbles constantly bob up and vanish. Multiverses are described by a few scientific theories that mention various possible scenarios, from separate universes that keep springing into existence all the time, to regions of space that are in different planes than our home universe. But there's one thing these theories agree upon. All of them suggest that the space and time we observe is not the only reality. It's impossible to explain all the quirks of our universe if it's the only one to exist. So it's either inventing newer theories that can shed light on certain properties of our universe, or accepting the fact that we're living in just one of many, many universes, all of which are different. One of the most widely known universe theories is called inflationary cosmology. This is the idea that right after the Big Bang, the universe expanded extremely fast and exponentially. Such rapid inflation could indeed explain loads of the properties of the universe we observe, like the distribution of galaxies. When this theory was suggested for the first time, it was perceived as science fiction. But with time, people started taking it seriously. Now, the theory claims that inflation might happen again and again, maybe even infinitely. And this could create constellations of bubble universes. Of course, none of these bubbles will have the same properties as ours. There may easily be places where physics as we know it doesn't exist. But even though some of these universes might look like ours, they all lie beyond the realm we can observe directly. There's also another theory, the many worlds interpretation. This one claims that there might be multiple branching timelines or alternative realities. And in each of those realities, our decisions play out differently, which means different outcomes. At the same time, the only reality you can perceive is the one where you live. If it's true, then the question is, where are all those other universes? Well, they most likely overlap in dimensions we absolutely can't access. And at the moment, it's not possible to travel between universes and dimensions. But maybe a few thousand years later, people will not only find a way to prove that parallel universes exist, but also invent a method to hop from one to another. Unfortunately, so far, there's no solid evidence that multiple universes are somewhere out there. All the proof we've got today is purely theoretical. Some experts even argue that it could be an unbelievable cosmic coincidence that the Big Bang created such a perfectly balanced universe as ours. Or, if parallel universes do exist, we might have just inhabited the one that had all the right conditions for our survival. It's still unclear whether the multiverse theory is even testable. Perhaps we just haven't thought of the right tests yet. Now, think about this. What if at one point you stopped existing in your home universe? I mean, the one you were born into. Then your consciousness was transported to a parallel universe. And that's where you're stuck now, watching this video. Write in the comments whether you think it's possible.
This is our home planet Earth and its satellite, the Moon. Zooming out, and here's our solar system. A bit more, the Milky Way galaxy. And we're a small dot among an infinite number of stars. Now, even farther out, a cluster of galaxies. Dots and swirls in the endless space. Further, there's Laniakea supercluster. That little dot here is our galaxy. Moving on, Hydra Centaurus supercluster. Huge clusters comprising thousands of galaxies are no more than a speck from here. Next, Pavo Indus supercluster. This is an area 200 million light-years wide. We can zoom out until we see the entire observable universe. Each little dot in here actually contains thousands of galaxies and quadrillion stars. Scientists speculate that our universe may look like a bubble, and that bubble might collide with another universe. Yes, other universes could exist. Actually, even a whole infinite number of those. All of them could have appeared after the Big Bang. The collision between them isn't impossible either. At least, it might have happened before. And the proof is here, in the direction of the constellation Uranus. This place is called Uranus Supervoid. It's about 1 billion light-years wide. By comparison, the width of our entire galaxy is only about 100,000 light-years. There's absolutely nothing in this place, and it may be a trace from an old collision between our universe and another. Scientists think they were passing by each other. When the distance between them was minimal, the gravitational forces of the bubbles began to pull toward each other, just like two drops of water trying to connect when they're close. But the speed of the universes was too high for them to continue interacting. So the other universe just tore out a piece of our bubble. There might have been about 10,000 galaxies in that void, and all of them were either destroyed or taken over by the other universe. Let's travel to the edge of our universe to see how this collision might have taken place. We're 10 billion light-years away from our home. Here, in another galaxy, we see amazing nebulae of different colors and shapes. And if you look in the other direction, there's a huge wall moving at us. All these bright sparks on it are enormous galaxies about to collide with us. But in fact, it's a humongous mirror that only reflects our universe. Here, space-time is distorted and begins to be pulled into another universe at a tremendous speed. The usual law of physics may simply stop working at this point. Gravity may disappear, and with it, all the stars would explode and people on the surface of planets would hang in weightlessness. But if the universes didn't go at a tangent but crashed directly into each other, things would be much scarier. The enormous amount of collision energy would probably cause an incredible explosion. Its force would simply destroy everything in our bubbles. Still, the two bubbles might begin to merge too. At first, all galaxies at the edge of the universes would be torn apart, but then the merger would begin. The galaxies would start moving chaotically. They would fly past each other, break apart, collide, and explode. The collision of two galaxies is an accident of enormous proportions, and it might happen to our home quite soon, in space terms. The Andromeda Galaxy is heading our way. It's a spiral galaxy about twice the size of ours, and there are about 1 trillion stars there, which is twice more than in our Milky Way. At the very center of this bright galaxy lurks a dark beast, a black hole. Its weight is 2 and 8 zeros of the Sun's mass. Red giants hundreds of times larger than our Sun. Pulsars emitting enormous amount of energy like spotlights. Rogue stars, and many large and small black holes. This soup of dangerous objects is moving toward us at 68 miles per second. A trip to New York to Los Angeles at that speed would only take half a minute. The disk of Andromeda can already be seen with the unaided eye on moonless nights. As time goes on, it'll get even bigger. As Andromeda gets closer to us, its gravitational force will begin to stretch the arms of our spiral galaxy. It'll begin to unwind. The stars and planets will lose their orbits. One possible scenario is that an unknown asteroid, or even a dwarf planet from the Andromeda Galaxy, will crash into the Earth at an incredible speed. Our planet will explode just like a balloon from this impact. Oh, goody. Another option involves stellar collisions. Our Sun would face another star. The bigger star will slowly begin to consume the smaller one. First, it will steal the light upper layers from it, and then it will eat it just like spaghetti. Or even like rigatoni. When a large star reaches its critical weight, it will burst. This explosion will destroy everything around it, including our solar system. Perhaps the shockwave will even reach other neighboring stars. Yet another scenario is that our solar system will be thrown into dark space. Imagine a tennis ball tied to a rope. You take the rope and spin the ball over your head like a sling. Then you let go of the rope and send the ball flying. This is what will happen to the Sun and all the planets around it. We'll find ourselves in dark and cold space. But life on Earth will not be affected. We'll still have our bright star to keep us warm. The only disadvantage is that all the stars in our night sky will disappear. And the most likely possibility is that the merger of two giant galaxies will have no effect on us at all. The thing is, the distance between stars and planets in space is enormous, so they can all just mix together and form one giant cloud. It would be like shoveling fine sand through a big sieve. The objects won't interact with each other. But the most interesting thing will happen to the black holes in the centers of our galaxies. Right now, there's a dense cluster of stardust and stars around them. As Andromeda and the Milky Way come closer together, they will begin to dance with each other. Gee, will it be the twist or the foxtrot? And when the black holes get close together, they'll begin to swallow all matter around one another. Billions of tons of colored stardust, asteroids, and star particles will fly toward the very center of either black hole. It might seem like this process happens very slowly, but it's an illusion. Super heavy objects like black holes warp the space-time grid, so time is much slower near black holes. And all objects that seemingly stay on the event horizon for weeks or even months are actually long gone. When the black holes finally come together, they merge into one supergiant black hole, but its mass is slightly less than the combined mass of the two dark monsters. Some of their weight is transformed into collision energy. This energy is released so strongly that its waves can be felt in other galaxies. Now, a huge black hole gathers all this dense and hot core of the two galaxies around itself. At some point, the black hole feels full and throws out powerful jets of energy into space. This is called an active galactic nucleus. It's one of the brightest phenomena in the universe and the most powerful source of electromagnetic radiation ever known. These jets may be more than 5,000 light-years long. By comparison, the distance from Earth to the nearest star, Proxima Centauri, is only 4.2 light-years. And the explosion that accompanies the jets has the power of 100 supernova explosions. Wow, blows my mind. The blast wave from this event could even reach the edges of a new galaxy, and this outburst would be visible from millions of light-years away. Now, there are dense clouds of multicolored dust at the center of merged galaxies. The weight of these clouds is so great that they begin to shrink and take on a round shape. Gradually, they become so heavy that they compress the core and nuclear reactions start inside them. The temperature begins to rise, and soon, boom, there's a supernova. It's a veritable fireworks show at the center of the galaxies. Stars erupt from the fog and form new hot worlds. At this point, the arms of the two galaxies that were previously pulled out slowly return to their former shape. The super-heavy center of our galaxy has such a gravitational force that it affects stars and nebula hundreds of thousands of light-years away. The galaxy's arms twist again, and we see the new and finished galaxy, the Milkomeda, or Milkdromeda. Hey, how about the Andro-Milky-Meda way? Blah blah blah. Well, that's hard to say.
There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions, and one of the people who tried to do this was Paramahamsa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahamsa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous studies of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy. And according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Basically, everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't actually be tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e. absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too. And these blocks are called electrons and positrons. But what holds these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before. And, according to the second law, these tiny invisible particles make up everything, from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. The field distribution in space, as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simply. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law 5. From only one fundamental universal constant, all the constants considered universal in contemporary physics are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales, from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So, this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept.
What do you mean by saying that there will be a little device in your pocket with all the knowledge of the world? People will be able to communicate with one another from any place on the globe at any time. And many machines will get artificial intelligence? Sorry, my friend, I can't believe this. It all sounds like a fairy tale. Perhaps that's how people from 1923 would have reacted if someone had told them how technology would change in 100 years. But how would we react if somebody from the future went back in time and told us about 2123? We don't need a time traveler to find this out because modern scientists can already predict how technology will develop in the next few decades. So let's start with the most essential thing: medicine. Research, diagnostics, treatment methods, all these will develop quickly. Doctors and chemists of the future will be doing their job along with AI assistants. They will be able to diagnose and treat diseases much faster and more efficiently. There will be nanotechnology that can cure severe health problems without surgery. Imagine millions of tiny robots getting into your body to handle all your problems. But along with this, new dangerous bacteria may appear in the world that will be difficult to cure. Nature and evolution always keep a balance. On the one hand, our medicine will defeat bad microorganisms, but on the other hand, it will only make them stronger. People will get huge health upgrades. It's possible that we will be able to defeat aging in a few decades, living for 200, 300, 500 years. All this can become a reality. Some people living today will probably regain their youth in the next 100 years. Pharmaceutical companies will create tools to improve memory and mindfulness. The most powerful machine in the world, that is, our brain, will become even stronger. Muscle and fat-burning tonics can turn a dream into reality. Imagine a device that trains your muscles while you sit on the couch and watch dinosaurs running in your yard through the window. Only it's not a window, but a TV that gives 20K image quality indistinguishable from reality. Integrating technology into human anatomy will completely change the appearance of people. How about digital tattoos or lenses with infrared vision that can change your eye color? Flash drives in your brain to store all the information from a video tutorial. Metal bones and super strong muscles. Energy. We may completely switch from lithium to solar batteries in the next 100 years. Imagine thousands of large satellites with solar panels flying around the planet and providing Earth with unlimited energy. We will also be able to get a lot of energy from wind and water, and all this will allow us to make discoveries faster and more efficiently. With the help of light energy, we will study the universe much better and possibly find extraterrestrial life. A research project called Breakthrough Starshot is already in development. Scientists and engineers are creating ultra-fast nanocrafts powered by light. These are tiny robotic probes that have various research tools and communication systems. Thanks to their size and speed, they will be able to reach the neighboring Alpha Centauri star system in 20 years. Modern spaceships will reach this point only in 76,000 years. Nanocrafts will allow us to study exoplanets not through telescopes but from up close. We will be able to see videos of these new worlds, explore their atmosphere, and find living organisms. If they are there, of course. But most importantly, we will understand which of these worlds are ideal for humanity. By that time, the colonization of planets will not be new to us because, within 100 years, we will surely send the first people to Mars. We will study its atmosphere, find sources of fresh water, build houses, and create a transport system. We will start bringing more and more products from Earth to the Red Planet and develop the economy between settlements on Mars. People will live in small communes under large domes where they can breathe without a spacesuit. The development of extraterrestrial technologies will significantly improve our economy and create many new jobs. Maybe we'll find some valuable material on Mars and start spending billions of dollars to mine it. Our gadgets and laptops will become powerful computing machines thanks to quantum computers. It will likely be the most profound revolution in the world of technology, even more marvelous than the invention of the internet. The internet is just a huge platform where we share information and knowledge with each other. But the quantum computer will give us more. It will be able to do things that the most powerful supercomputers today can't even come close to. Calculations for space travel, genetics, chemistry, and physics. Currently, people are building large farms to mine Bitcoin. One quantum computer may be able to do this 1,000 times faster. Combining quantum technologies and artificial intelligence will contribute to the technological singularity. This is a level of development when the speed of technological invention accelerates and progress becomes uncontrollable. People lived for several thousand years using the same technologies. And then, in the last 100+ years, everything changed. Thanks to electricity, the internal combustion engine, penicillin, and other discoveries, we could create antibiotics, cars, the internet, cameras, video games, and thousands of other things. And all this in a very short period. In a sense, this was also a technological singularity. So, quantum computers and artificial intelligence will be the next booster, like the Industrial Revolution before, thanks to which the world will begin to change every day. Virtual reality glasses will become archaic in the future. People will wear transparent lenses with a digital interface or install chips in their brains. Scientists will be able to recreate the DNA of dinosaurs and mammoths. There may be technologies for recording dreams. Predicting the development of progress after a technological singularity is quite difficult. The human brain may not adapt to these rapid changes, which can lead to serious mental problems. Today, spending many hours watching short videos on social networks puts a lot of pressure on the brain. What will happen next when virtual reality becomes as real as ours? A simulation of the perfect world will draw many users away from real life. Our perception of the world works thanks to the brain, which processes signals through our senses. For example, music enters our ears, where the eardrum receives sound waves, then transmits them through a special channel in the form of a signal. And then, these signals reach the brain, which turns them into the sounds of music. Now imagine that these waves can be sent to the brain simply by stimulating its neurons with an electric current. You will hear music that doesn't really exist. So in the future, virtual reality headsets may appear. They will stimulate millions of brain neurons responsible not only for sounds, but also for smells, touch, and vision. There will be no difference between real life and virtual life for you. Let's hope that people will venture out from there to at least drive flying cars. In the future, they will be as ordinary as modern vehicles. You will be able to travel long distances with the help of the Hyperloop trains moving inside vacuum tubes at the speed of sound. Going on vacation to space stations or Mars will be as cheap as traveling to another country today. Thanks to the growing competition and lowering prices, cool technologies will be available to everyone. Remember how it was with cars in the 20th century? Only the richest had them. But after a few decades, ordinary people with average incomes started buying beautiful vehicles. Even if you can't buy a flying machine in the future, you'll be able to take a ride in a sky taxi. People will have to study constantly to keep up with the technologies. Not everyone will withstand this stress. Artificial intelligence will render millions of people around the world jobless. But in the end, all this will benefit us because there's no progress and development without overcoming difficulties.
Guess what? The universe can get actual scars, just like when you fall off a bike. Well, here's why. Before the Big Bang, the universe was extremely hot, dense, and full of energy, and it seemed like everything was going well, until that all changed about 13.8 billion years ago. Then the universe exploded. After the blast, it expanded incredibly quickly. Our human brain can't even perceive how fast that expansion was. Sometime later, the universe started cooling down. As it did, giant, terrifying scars cutting through space-time appeared all over the place. And if we study these scars well, we can even get insight into time travel. These days, we call these scars cosmic strings. They're like stretch marks that appear when the skin expands too quickly. Or we could also compare them to cracks that form in the ice when it freezes. These strings are likely very thin, about the size of a proton, a positively charged subatomic particle. Yes, subatomic means smaller than an atom. The strings are also extremely dense and can stretch for light years. Now, imagine these cosmic scars floating through space, not interacting much with their surroundings. When two cosmic strings pass each other, they could warp space-time in such a way that it creates a time machine. If you were to travel along a certain path around these strings, you would end up returning to your starting point at an earlier time, which is traveling back in time. Now, let's admit it, this idea sounds like something from science fiction, but it's supported by cosmic string theory, and the math behind it seems to work. Unfortunately, no one has observed cosmic strings yet, so for now, it's still a theory. In 1991, one physicist proposed an idea for how cosmic strings could enable time travel. If two infinite cosmic strings passed each other in parallel, they would warp space-time, creating a time loop. This loop would allow someone to travel back in time. Even better, this idea doesn't contradict Einstein's theory of general relativity, which suggests that large objects can bend space and time. These bends in space-time could allow a shortcut through time. His now well-known concept of closed time loops also helps explain how wormholes might work. So, a wormhole is basically a theoretical tunnel connecting one place in space to another. Some people believe that by using such tunnels, we could create shortcuts for incredibly long journeys through the universe, which would allow us to visit other star systems and galaxies. So, let's say you manage to create a wormhole and even accelerate one of its ends to near the speed of light, and then you send it back to where it came from. Well, at that moment, those two ends are not synced anymore. One is in the past, while the other is in the future. And if you somehow manage to walk between them, you'd be time traveling. You could do something similar by placing one end of the wormhole near a powerful gravitational field, like a black hole, and keeping the other side near a weaker gravitational force. This way, according to the theory of relativity, time would pass more slowly nearer to the strong gravity side, and it would allow a particle or another chunk of mass to remain in the past relative to the other side of the wormhole. At the same time, if you decided to create a wormhole, you'd have to keep in mind that they are super dangerous. They might collapse all of a sudden. They're likely to be highly radioactive, or you could come into contact with toxic exotic matter inside. But let's get back to the math behind the cosmic string time machine idea. Admittedly, it is solid, but it doesn't mean such a time machine is possible yet. To use this way of time travel, we'd need to reach near light speed, and it might be impossible. According to Einstein's relativity, the faster an object travels, the more energy it needs to continue speeding up. In other words, we don't yet have the technology or energy sources to accelerate a spacecraft to these speeds. The idea of two infinite cosmic strings is also questionable because we can't create something that's infinitely long. So, while this time travel model is mathematically sound, the infinite nature of the strings would make this exact model impractical. At the same time, some scientists still believe that cosmic strings are a better possibility than most other models, like wormholes. In any case, before we can start considering time travel, we need to discover cosmic strings. Luckily, there's a group of astronomers working to detect low-frequency gravitational waves by measuring signals from a type of star called a pulsar. Now, pulsars send out regular pulses of radio waves, and by measuring small changes in the timing of these pulses, scientists can detect subtle shifts in space-time. Those changes are caused by gravitational waves, which are ripples in space-time. Now, so far, we've only detected gravitational waves coming from black holes. But in 2020, there was one strange signal that didn't look like it came from black holes. It could be coming from cosmic strings. And here, we need to mention string theory. According to it, the universe is made up of more than just the 4 dimensions of space-time. There are additional dimensions that are hidden from us. Plus, the basic building blocks of the universe aren't particles, but tiny vibrating strings. These strings can vibrate at different frequencies to create different fundamental particles. These strings, from string theory, could have stretched out during the early universe and become the very cosmic strings we've discussed. In the coming years, we might get more information about them from a space-based gravitational wave telescope called LISA. It's supposed to launch in 2035. But if the signals picked up in 2020 really came from cosmic strings, it could mean a huge breakthrough in physics. In this case, string theory would become the right framework for understanding the universe. It would completely change the way we think about the building blocks of our reality. On the other hand, even if the signals don't turn out to be from cosmic strings, this discovery would still be important. It would give scientists more information on what cosmic string signals might look like in the future. And while we're not yet at the point of time travel, the discovery of cosmic strings could take us one step closer to understanding the mysteries of the universe and maybe even the possibility of traveling through time. Now, time travel is a popular theme in science fiction, but in fact, moving forward in time happens naturally. Right now, you are traveling into the future at a steady rate of 1 second per second. However, scientists have discovered that this rate can change depending on speed and gravity. Einstein's special theory of relativity explains that time slows down as an object moves faster. The closer you get to the speed of light, the more slowly time passes for you, compared to someone who isn't moving at all. The general theory of relativity adds another factor, gravity. The stronger the gravitational pull, the more slowly time moves. Near massive objects, such as the surface of a neutron star, black hole, or even Earth, time runs more slowly than it does far away from these space objects. If someone were to stay near the edge of a black hole, where gravity is incredibly strong, only a few hours might pass for them, while thousands of years would go by for people on Earth. If they returned, they would have effectively traveled into the future. This is a real and scientifically proven effect. A real-life example of time travel, though on a tiny scale, can be witnessed in space missions. For example, this cosmonaut spent a total of 748 days aboard the space station Mir during 3 separate missions. Because Mir was moving at high speeds relative to Earth, it experienced time dilation. As a result, he aged 0.02 of a second less than had he stayed on the ground. Now, this difference may seem tiny, but it shows that time moves differently depending on speed and location. But while traveling to the future is scientifically possible, traveling to the past is much more complicated and controversial, and leads to logical paradoxes. Imagine you throw a billiard ball into a time machine. It travels to the past and collides with its earlier self. This prevents the ball from ever entering the time machine in the first place. A contradiction. Okay, people, hold it down. End of the world, take 1. Anytime, Sydney. At first, it looks like kind of a fireball. It grows bigger and bigger by the minute. Soon it seems to be larger than the sun. People are frozen to the spot with their eyes glued to the sky. They haven't realized yet they have to run for their lives, not that it's going to help. The asteroid slams into the planet with enormous force. It doesn't stop moving until it gets through the crust to a depth of several miles. Thousands of cubic miles of solid rock instantly turn into vapor. Everything and everyone close enough to see the crash don't live longer than a few seconds. The ground around the impact crater is covered with thousands of feet of hot ash, grit, and rubble. Mere seconds after the collision, grass, trees, and shrubbery for many miles away burst into flames. But that's not all. The crash sets off a series of natural disasters, like tsunamis. What didn't burn down within the first several minutes gets flooded. In some places, tsunami waves are higher than 1,000 feet. Earthquakes start to shake the planet. Less than an hour after the asteroid crashed into the planet, a gust of wind whips through the world. Its speed is more than 600 miles per hour. The hurricane flattens down everything that is standing and scatters debris for miles around. A bit farther away from the impact zone, the sky is starting to darken. That's why beautiful shooting stars seem even brighter. But those aren't stars. That's debris raining back on the planet. They re-enter Earth's atmosphere glowing ominous red because of the infrared radiation. These are just the first hours after the crash, but the sky is almost completely black. By the time it begins to get lighter, there's no life on the planet. The ash is still in the air. When it rains, the water gets highly acidic. Fires keep raging. They produce tons of toxins that destroy the ozone layer. Earth loses its last shield against the radiation from the sun.
Okay, I don't like that one. Too much doom and gloom. What else we got?
Well, or the end of the world could look quite different. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. The climate all over the planet starts getting colder and colder. It becomes impossible to live close to the poles. All life gathers near the equator. Quite soon, half of the planet turns into an icy desert. There's a lack of food and other resources. It's getting darker and darker. There's not enough light for plants to get energy. They wither, and animals that used to feed on them can't find food and go extinct. The farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth gets too far away from its main source of light and heat. It turns into a lifeless piece of rock covered with a thick layer of ice.
Nah, I don't like that ending either. Leaves me cold. Anything else?
Or the sun might expand and turn into a red giant. If it happens, it'll change the entire habitable zone of the solar system. It starts when our star runs out of the hydrogen in its core. This triggers several reactions. In the end, the core heats up and gets denser, which makes the sun way larger. During this transformation, the sun swallows Venus, Mercury, and Earth. The expanding star engulfs our planet even before it reaches the tip of its giant red phase. It still has around 500,000 years to grow. As soon as Earth is inside the sun's atmosphere, its orbit changes. The planet spirals inward, inside the star's raging heat. But no one and nothing is around to witness it. Long before that, the sun evaporates all the oceans on our planet. In the end, Earth becomes molten. Molten, huh? Nah, that's too hot to try. Try again. Okay. Or it might be something vastly different. People all over the world wake up in the middle of the night. It's as light as in the morning, but it's not sunlight. The skies are illuminated with countless auroras, red, green, purple. They appear even in the regions where no one has seen them before, like the Bahamas, Jamaica, or Hawaii. The sun is a gigantic, constantly changing ball of burning gases. Every once in a while, it spews out bursts of energy. Those are solar flares. They are often accompanied by coronal mass ejections. So this time, the sun has produced an epic geomagnetic storm and unleashed it at our planet's protective layer. Waves of charged particles slam into Earth's atmosphere. The planet's magnetic field isn't powerful enough to stop this. It gives way, and the storm hits Earth, causing havoc. It starts by disrupting GPS and knocking out satellites. After that, the storm interferes with satellite communications. But one of the worst consequences is connected with power grids. Power surges caused by the particles coming from the sun damage giant transformers. Earth is left without electricity for years. There's no light, no computers, no phones. Water supply systems are out of order. There's no food in supermarkets. There's no electricity, and people can't reboot the already broken power grids. Wildlife takes over the planet, creating some kind of a post-apocalyptic world.
Yeah, I think we should let the monkeys run things for a while. They can't do any worse. Alright, what else?
Ooh, if you had the gamma ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, then disappear again. Those flashes are gamma ray bursts. One of them might wipe out Earth's atmosphere. The flash that's going to ruin our planet was born in a faraway galaxy where two collapsed stars merged. It's immensely powerful. It carries 10 quadrillion, which is 1 followed by 16 zeros, times as much energy as our sun. When the burst is 1,000 light-years away from Earth, it's already shining as bright as our sun. Our planet's atmosphere is trying to protect us once the burst comes too close. But this shield doesn't last. The radiation is so powerful that it literally cooks the atmosphere. It creates nitrogen oxides that destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun hit Earth's surface at full force. They wipe out tiny plankton in the ocean. These plankton produce from 50 to 70% of all oxygen on our planet. They disappear, and soon there's a severe lack of oxygen. Terrestrial life vanishes first. After that, living creatures start to disappear from seas and oceans. In the end, the heat and ultraviolet light coming from the sun turns the planet into a huge chunk of barren rock.
Never mind, I don't like any of these. Let's just keep the Earth the way it is, okay? Hey, Sydney, why don't we blow up Mars or something?
A giant wormhole, or simply said, a connection between regions of space-time, opens up in space near Earth. Our world faces chaos unlike anything before. Satellites incinerated, skies ripped open by radiation storms, entire power grids blacked out. The atmosphere is swelling and scorching, the oceans are boiling, the magnetic shield is shattering. Suddenly, the wormhole destabilizes. Space-time starts to unravel, tearing Earth apart from the inside out. People are seeking shelter, but nothing can save them anymore. Look at this devastation. This isn't just a sci-fi scenario. It's a cosmic apocalypse waiting to happen and rewrite the fate of humanity. The thing is, some black holes might actually be secret space portals. It may sound like something straight out of Stranger Things, but it's not. Scientists have been wondering for years if some black holes could actually be wormholes in disguise, tunnels through space and time. And now, a new study says this might actually be possible, at least in theory. Wormholes are like cosmic shortcuts that let you pop out in a totally different part of the universe. Unfortunately, we've never found one, and the whole concept still lives in the land of what if. Here's the problem. To actually make a wormhole work, you'd need something called negative energy. That's not just rare. It doesn't even exist in the regular universe. Maybe in some weird world of quantum physics, but even there, it's super uncertain. Still, scientists have a wild thought. What if some black holes aren't just giant space vacuums that swallow everything around them, but are really hidden wormholes? The odds of that are tiny, like winning the lottery while getting struck by lightning and discovering extraterrestrials at the same time. But mathematically, it's not impossible. That's where the new study comes in. Researchers looked at a weird type of black hole called a Schwarzschild black hole. These ones don't spin, don't have electric charge, and, very predictably, are totally hypothetical. They're just the math version of a black hole, not something we've seen in space. In any case, the team studied something called quasi-normal modes, which is just a fancy way of saying how space vibrates around a black hole when you mess with it. These vibrations don't go on forever. They fade out like the ringing sound you get when you hit a bell. By analyzing those space-time vibes, scientists tried to figure out if they could tell the difference between a regular black hole and a wormhole pretending to be one. It turns out that it's super hard to tell this difference. But maybe that's the point. Wormholes might be hiding in plain sight, wearing black hole costumes like it's space Halloween. Wormholes could copy a black hole's behavior almost perfectly, at least on paper. The researchers uploaded the whole study to ArXiv, which is where science nerds drop their ideas before they hit the big journals, and it's already been published in Physical Review D, which is a serious physics magazine. The coolest thing, though, is that it isn't a brand new idea. Scientists have been debating this whole black hole or wormhole thing for decades. Back in 2021, some researchers wondered if the giant black holes at the centers of galaxies, called active galactic nuclei, were actually wormhole entrances. And in 2022, a team in Bulgaria said that the light coming from a wormhole could look almost exactly like what comes from a black hole. There's also this sci-fi level theory that some black holes might be paired with opposite twins, called white holes. A white hole basically spits stuff out instead of sucking it in. Together, a black and a white hole could form a wormhole tunnel. But no one's found a white hole either yet, so that idea is still just theory. By the way, in this latest study, the authors have shown that wormholes and black holes not only look similar, but also sound similar. At least in how space-time shakes around them when they get hit with something. So our next move should be fine-tuning our scientific models, especially near the part of the wormhole called the throat. Scientists want to see if wormholes could fake even more black hole-like behavior, but it's tricky. Some of the math gets super hard. In any case, how about finding out more about these mysterious wormholes? You've seen them in every second sci-fi movie, magical space tunnels that let you skip across the universe. Einstein was the first one to have dreamed them up. Wormholes are still 100% hypothetical, and we've never spotted one. But that doesn't stop people from theorizing. Like, what if a wormhole started sucking in matter like a black hole does? If a wormhole started eating stuff like dust, gas, or space debris, it would create a plasma tornado, a literal space firestorm in its throat. And this twisty storm would eventually blast out the other side of the wormhole, firing hot plasma at nearly 125 million miles per hour. That's about 1/5 the speed of light. It would also be insanely hot in there, so hot it could probably trigger nuclear fusion. Of course, all of this is still just theoretical. No one's seen a wormhole do this. No one's seen a wormhole do anything, actually. But the math says it could happen, if we ever find a wormhole. The bright side of it all is that we would probably spot an event with so much drama. Even though wormholes don't have an event horizon, aka the point of no return, like black holes, they still bend light. Normally, you might not be able to see something like that, but this thing is so absurdly bright from the plasma firestorm that you would actually see it glowing in space. Think of it like a black hole, but with a glowing center instead of just darkness, and a jet of flaming plasma shooting out one side like a broken space faucet. Still, don't get your hopes up for spotting one anytime soon. Even if we did find a wormhole, it probably wouldn't last long. It could break apart or transform into a completely different type of space-time before we even realized what we were looking at. Plus, keep in mind that wormholes might look almost exactly like black holes unless you know what kind of light polarization, how light waves line up, to look for. Now, let's talk a bit more about black holes themselves. You're likely to know them as insane space beasts that suck up everything nearby: gas, dust, even light. And once something crosses a black hole's event horizon, it's trapped forever. Scientists say that inside, everything gets crushed into a tiny point called a singularity, where the usual rules of physics totally break down. But back in 2010, a physicist named Nikodem Pavlovsky had a crazy idea. What if black holes don't have singularities? Instead, what if the center of a black hole is actually a doorway to another universe? Maybe our entire universe was born from matter shooting out of a black hole in some parent universe. Pavlovsky's theory uses something called torsion, which is like a weird gravitational twist that stops matter from getting crushed infinitely. Because of torsion, instead of crashing into a singularity, matter inside a black hole can create a tunnel, a so-called Einstein-Rosen bridge, or simply a wormhole, connecting a black hole to a white hole. So, imagine matter falling into a black hole in one universe, then popping out of a white hole in another. Pavlovsky thinks this could explain the Big Bang, but as a big bounce, meaning the universe keeps cycling through phases of expansion and contraction, not just one huge explosion. Sadly, if such a tunnel existed, it would be a one-way trip. Nothing would come back through to the original universe. Some scientists are still skeptical because torsion hasn't been proven yet, but other experts think Pavlovsky's model is super promising. They even go further and say that our whole universe might be living inside a giant black hole hundreds of billions of light years wide. Now, we just need to figure out how to test this. Future space studies might give us more clues, like checking if our universe is closed, which basically means that it's curved without an edge, or digging deeper into cosmic background radiation, which is the leftover glow from the Big Bang.
Black holes tearing apart enormous stars, pulsars spinning at incredible speeds and emitting powerful beams of energy, colorful nebulae with fireworks of newborn stars, galaxies of every possible color and size. All of these are found within our universe, but it's not infinite. It has a boundary, a literal wall, and beyond that, there's an absolute nothingness. Right now, we're going to make a journey to that wall. But first things first, our universe is like a humongous nesting doll. If you open it up, there's a smaller one inside. It's a galaxy. Inside that is an even smaller doll. That's our solar system. And the smallest doll of all is the Earth. Each of these dolls has boundaries that we're going to cross. For that, we'll need a spaceship, and a big one. It also has to be able to move 100 times faster than the speed of light. You get on board and start the engines. 62 miles above sea level is our first boundary. That's 10 times higher than passenger planes fly. This point is called the Kármán line. It separates the atmosphere of the Earth from outer space. Now we fly further to the edge of our solar system. We turn on the hyperdrives and fly past Mars, Jupiter, Saturn, Uranus, and Neptune. We've traveled a distance of 100 astronomical units. 1 AU is the distance from Earth to the Sun. And here's the boundary of our solar system, the heliosphere. Here, the speed of the solar wind decreases rapidly. First, it drops from 620,000 miles per hour to the speed of sound. Then, there's a layer called the heliopause. This is where the wind almost vanishes. And then, our ship experiences a bow wave. This is where we feel the force of the interstellar wind, which collides with the boundary of our solar system. When you pass this boundary, you find yourself in the dark of interstellar space. And here, you can find two human-made objects that made this trip for the first time in history. They're Voyager 1 and Voyager 2. Voyager 1 crossed that boundary in 2004. Voyager 2 did it in 2007. These space probes discovered that the heliosphere is not a perfect ball around the sun. Its southern boundary is 10 AUs closer to the star than the northern one. So, we're moving in interstellar space and will soon approach a stone wall around our solar system. 200,000 AUs further, and there it is. This wall of rock is the Oort cloud. In fact, it's a pile of asteroids that surround our world. Scientists speculate that the Oort cloud could be the source of comets and meteorites that fall to Earth, but they're so sparse that we easily fly between them. Now we're in complete darkness. The Milky Way is about 106,000 light-years wide. In a conventional rocket, it would take billions of years to fly across that distance. But you throttle to the max. You masterfully fly past the stars and planets as if on a racetrack. And within minutes, you're at the edge of our galaxy. There's no more interstellar wind. All you see are bright dots somewhere in the distance. These dots are huge galaxies. We need to look at a map to make a route to the edge of our entire universe. You're here, near the Milky Way galaxy. It's part of a cluster of galaxies called the Laniakea supercluster. But even this huge thing is like a little street in a big city. Zooming out, we find Hydra Centaurus supercluster. Thousands of galaxies on the map look like little dots. Maximum zoom out. This is our entire observable universe. We thought it was infinite, but we may have proof that it has a boundary. It's here, 10 billion light years away from our home. Even if you travel at the speed of light, a trip there would take twice as long as our whole planet has existed. During that time, the sun will either fade away or explode like a supernova, destroying our entire solar system. And if you can live that long and then return home, you will see that our galaxy is there no more. It's long since collided with the Andromeda Galaxy and merged into one big cosmic body. Luckily, your ship is able to warp space-time so that this journey will literally take a few seconds. Boom! Congratulations! You've arrived at your destination, the Eridanus supervoid. Some scientists believe this location is the evidence of collisions of our universe with something big enough to leave such a large scar. The Eridanus supervoid is an empty and cold space 1 billion light-years wide. If you think of this void as a cup, it would fit at least 10,000 galaxies, and it appeared after an accident of gigantic proportions. The object that crashed into our universe was another universe. Yes, other universes may actually exist. Imagine that our entire universe is a huge bubble that contains all the clusters of galaxies in the observable universe. There could be an infinite number of such bubbles. They could have been born during the Big Bang. These universes may be different from ours. They may have other galaxies and nebulae. But these bubbles could also be parallel universes. This means that if you chose cereal over oatmeal in the morning, in another universe, your twin would choose the oatmeal. Every choice you ever made in life had completely different consequences in a parallel universe. And because the number of choices are infinite, there's a whole infinity of parallel universes. So, like a regular bubble, our universe has a wall that is near the Eridanus supervoid. Long ago, another bubble flew past ours. As they approached each other, their gravitational fields began to interact. Our boundary wall began to deform and pull toward the other universe. The same thing happened on the other side. Then the walls of our universes came into contact. But as these bubbles moved, their connection began to break, and the other universe just ripped a huge chunk of ours. A cold void was formed at the point of collision, and that was the Eridanus supervoid. The problem is that the universe looks the same to the observer, regardless of point of view. For example, imagine a basketball hanging in the air. Now, if we put an ant on the ball and tell it to find the edge of the ball, it will start running around it, making an infinite number of circles. But the landscape around the ant will not change. All it will see is a rounded horizon. That's because the ball remains the same from any point of view. The same thing happens to us when we try to find the edge of our universe, all because we imagine the world in three-dimensional space, and our view is limited. For example, you see an ordinary square in two-dimensional space, but if you add depth and change the point of view, voila, it's a cube. If we could see the universe in four-dimensional space, a square might be something completely different. But maybe we can leave our home bubble. The key to traveling to another universe might be inside a black hole. A black hole is one of the most mysterious objects in the universe. They're so heavy, they warp not only space, but time as well. It's like putting a heavy boulder on a net. The net will sag, and the closer you get to the boulder, the stronger the curvature is. Once you're in the gravitational field of a black hole, you can't leave it. We still don't know what might actually be in the heart of a black hole. Some scientists speculate that white holes also exist. Theoretically, they should be born along with black holes. Except for the color, they're the exact opposite of black holes. Nothing can come close to a white hole. At the moment, there's no data on such objects. but general relativity theory suggests they do exist. There's also a theory that a black hole may be a passage to another universe. When you get into a black hole, you can come out the other side through the event horizon of the white hole. So you bypass the boundary of the universes and find yourself in a completely different world. But we may have proof that a white hole exists. In 2006, scientists discovered an unusual burst of energy somewhere 1.6 billion light years away from Earth. This burst was unique. It didn't look like a supernova explosion or even the merger of two black holes. Some astronomers believe it was the birth of a white hole. But because it was unstable, it was destroyed almost immediately. This process was reminiscent of the birth of our entire universe, the Big Bang. So, scientists called it the Little Bang.